Good morning, students. Today we are going to discuss IIT-JEE NEET Foundation. The topic is the light. In the light, we discussed lens makers formula. See, what is lens? Lens is a refracting medium. Lens is a refracting medium which is combination of two mirrors. If they combine two mirrors, is called lens. The refraction takes place. There is a bending of light. See, in the first surface there is certain bending will be there, and in the second surface there is certain bending will be there. So that there are two refractions will takes place, and finally image comes out. That is, see, lens. Lens is made up of two different surfaces. So there is a convex lens, concave lens, and plano-convex lens, plano-concave lens, etc. These are the different types of lenses. So lens, see, thick lenses you take. Thick lenses, image formed by the thick lens if you take. So that is Cartesian sign convention. Use normally 1 by f is equal to 1 by v. So the same thing, 1 by v plus 1 by u. Object distance plus image distance, focal 1 by focal length. This is the formula for the lens. For example, you take focal length of some value, the lens equation. See, in the lenses the Cartesian sign conventions also should be taken. See, Cartesian sign convention. You take this is the convex lens. In the convex lens, if you observe, see, double convex lens. Here the rays which are coming from the object and incident on the lens, and there is, so refraction takes place and image is formed here. Let us take this, the object. This is an object. See, this is an object and this will be the image. So the rays which are parallel to the principal axis, this is the principal axis, or passing through the optic center. Those rays are going to bend like this and image is going to be formed here. So the distance from the lens to the image is called image distance. The distance between object to the lens is called object distance. See, the rays which are, there are two focal points will be there. One is called, see, left, another one is right. The focal length is nothing but the principal focus. The principal focus will be there. So where image, whatever the length, the ray which is parallel to the principal axis passes through the principal axis at some point, that point is called principal focus. So this principal focus and the lens, optic center, the distance between principal focus to the optic center is called focal length. It is denoted by f. Focal length, it is denoted by f. So in this case, what actually he is trying to do, see, there are some Cartesian sign conventions he is explaining. Cartesian sign conventions are nothing but when you are taking the values of, see, object distance and image distance. If image is above the principal axis, what should be taken? All these are sign conventions should be taken. The first point, all figures are drawn with the light traveling from left to right. Better to follow one method. All should be drawn from left to right. The rays, see, you may get confused sometimes if you draw from right to left, left to, so that's why you maintain that you always draw from left to right. All distances are measured from the reference surface. So such as refracting surface, the distances also should be taken left of the surface or negative. See, the refracting surface, left of the refracting surface should be taken as negative, and the right of the refracting surface should be taken as positive. If the rays are convergent, see, the refracting power should be taken if the power is, see, refracting by converging rays, if it is formed, so that may be the, see, convergent is positive, the focal length of such surface is positive, that you have to take it as focal length is, for a focal length of convex lens is positive, concave lens is negative, that you have to remember, don't get confused. The distance of real object is always should be taken as negative, the distance of real object is negative, the distance of real image is positive, the distance of real image is inverted image is positive. So the heights above the optical axis are positive, heights above the optical axis are positive, heights below the optic axis are negative. Angles measured clockwise should be taken as negative, anti-clockwise should be taken as positive. These are all Cartesian sign conventions. Cartesian sign conventions in the lens. See, the lens equation 1 by f equal to 1 by v minus 1 by u, or 1 by I minus 1 by, here what it is taken. See, Newton's formula. What is Newton's formula? Newton's formula is, see, XOXI equal to f square. This is the Newton's formula in the lens, or in mirrors also the same formula. XO is nothing but when? XO is the distance between focus to object. The distance between focus to object is called, so that is the distance between focus to image, that is xi. XO into xi is equal to, or x1 into x2 is equal to f square. F is nothing but focal length, or so you can take it as focal length. Object distance is, so that is O, it is here, or u object distance, and v is the image distance, of course. So this is the basic formula of Newton's formula. See, there is a simple derivation is also there. So 1 by f equal to 1 by u plus 1 by v. From that only you will get these values. Coming to the, see, the lens, the image sign conventions and other things. See, what is power of the lens? Power is nothing but the reciprocal of focal length. The reciprocal of focal length is called power. Power is measured in diopters. Power is measured in diopters. And another important one is lens maker's formula. What is lens maker's formula? Lens maker's formula is nothing but, see, it is for a thin lens, you can use 1 by, see, the formula is 1 by f equal to, you can write like this also, this is another way of writing, 1 by f equal to mu minus 1 into 1 by r1 minus 1 by r2. This is the lens maker's formula. 1 by f can be written as power of the lens, and mu can be written as, here mu relative, okay, mu r, that is nothing but mu 1 by mu 2 if you write, or see, mu lens minus, if you take subtraction, mu 1 by mu 2 minus 1 into 1 by r1 minus 1 by r2. The same formula you can express in this form also. Lens maker's formula, important in the optics. R1 and R2 will do the problems in the next video. So by using lens maker's formula we can solve the problems. And the refraction of the lenses, the refraction, how it is going to be takes place, the refraction of the light. Of course, in the lenses, See, positive lens and negative lens. Positive lens is nothing but the convex lens, if you take it as it is positive, and concave lens if you take it as negative. Object is there here, lens equation. Real image formation if you take here, real image. See, lenses, what are the different? Convex lens you take. See, convex lens, there are 6 cases will be there. The first case, if object is there, infinite. See, image is formed at the focus. If object is there at infinite, image is formed at the focus. See, let us take, see, this is the convex lens, principal axis, the rays. See, let us take the rays which are parallel to the principal axis. So they refracted and they bend like this. The another light ray refracted and bend like this. This is, see, object is at infinite. Object is at infinite. Image forms at principal focus. Image forms at principal focus. See, in another case, let us say convex lens. See, in the convex lens, the principal axis, if object is here, AB is the object. See, the rays which are parallel to the principal axis and it bends, and the another light ray passes through the, now object is there beyond center of curvature. Object is there beyond center of curvature. Image, where it is going to be formed? Here there is a focus and there is a center of curvature. If object is there beyond center of curvature, let us say C1, F1, F2, C2. See, the image forms between, see, here image is going to be formed. This is the B dash, A dash. Image, object is there beyond center of curvature. Image forms between F2 and C2. It is a real inverted image. Real inverted image. So this is one important, okay, so the position, location of the object where image is going to be formed. Another one if you take, see, let us take, the object is there at center of curvature. See, let us say this is C1 and F1, center of curvature, this is F2 and this is C2. See, object is there at center of curvature. Object is there at center of curvature. Image forms at the center of curvature. Image forms at the center of curvature. Here only image is going to be formed. See, something like here only, same, at the same place image is going to be formed. C1, C2 image is going to be, it is a real inverted same size image. Real inverted same size image. So another case, if you take the convex lens is there. See, the principal axis, object is there between C2, C1 and F1. Object is there between C1 and F1. So image forms, okay, F2 and C2. Image forms beyond, see, something like beyond center of curvature. Beyond C2 it is going to be formed. See, image is going to be formed somewhere here. It is the real inverted magnified image. Real inverted magnified image. So next case, if you take, see, object is there at center of, see, at center of curvature is over. See, something like C1, F1, object is there at focus. Image forms, see, image forms at infinity. These are rays are parallel. See, that's why image forms at infinity. If object is there at focus, image forms at infinity. If object is there between optic center and principal focus, last case, it's a virtual erected image which is going to be formed. Virtual erected image is going to be formed. These are the 6 cases of the convex lens. So similarly, concave lens, it may not be 6, it is only 1 or 2 cases will be there. So in that way, the image formation will be there in the lenses. So thank you for watching this video. We'll continue in the next video.